Now let's discuss collections in more detail. Typically, in an object, you store one or more fields that contain values, so data, and also some methods that process this data, these fields. But all of these are about a single item. When you need to store information, store and process information about multiple items, then you need a way of putting them in a collection. So you define a collection as an object which is composed of several items this time in a single data structure. So some of the collections we are going to discuss will maintain an ordering, which means in the collection I will be able to say this item comes before or after the other. And in some collections, we will not have any ordering. Also, in some collections, we will allow multiple occurrences of the same object. So we will call these duplicates, two or more. Whereas in some of the collections, each entity, each item should be unique. In general, if you look at the concept of an array is very roughly, very crudely, it is like a collection, but please note that officially an array is not a collection. For each collection, we'll have several methods. We already discussed some of them earlier, like adding methods, adding elements into a collection, removing elements from a collection, removing all elements in a collection, checking whether the collection contains a specific element or not, learning what's the number of elements in that collection is, whatever. There will be different types of collections, and each type actually is implemented with some particular kind of data or operations, methods in mind when we're designing. Some of these collections would be lists, bags, stacks, queues, set, maps, graphs, whatever. So we said we're going to see this figure over and over in this chapter. So let's remember that we're talking about the collection at the moment, which is here at the top, which could be implemented either as a list or as a set. So one thing we should keep in mind is the list implementations, like array list and linked list implementations, always have some ordering in mind. So in other words, both in the case of array list and linked list, we say this element comes before this element and after that element. There is an ordering between the elements. Whereas in the case of set implementations, as we will see, we don't care about their orders, but the important thing is whether it is in the set or not. So in general, in Java, when we talk about the collection interface, we define the collection interface, which is available in the Java util, remember, as collection of some type E. Again, E here is a placeholder called a generic class or a parameterized class. So we're talking about, for example, collection of string, collection of student, collection of course, whatever. So they could be there could be different kinds of collections. Now, we already discussed what an interface is. So if a class claims that it's implementing the collection interface, then it should provide the following methods. Well, we already discussed add value. Add value adds an element to the collection, but we discussed it in the concept of lists where there was ordering, remember. So we said add appends this value to the end of the list. Appending, remember, means adding to the end. Whereas in this case, collection is a more general discussion. There could be ordering or maybe not. Therefore, the add method we have in collection does not talk about ordering. Therefore, we don't say it's adding to the end. We just say it's adding it to the collection. That's it. We will have several methods that end with the word all, like add all, contains all, remove all, retain all. In all of these methods that end with all, note that the parameter here is not an item, but it's a collection of items. Okay? Remember, in the case of add, we were trying to add a single value, a single item, whereas in the case of add all, it's a collection, therefore there are several items in it. Now, note that add all is being called for the current object, which is hopefully a collection, and as a parameter, you're giving the name of another collection. So in the case of add all, for example, you're calling the add all of the current object. So the current object takes as a parameter the name of another collection, goes to that collection, and copies each and every element of that collection to the current collection. Okay, so the current collection grows. Nothing happens to the other collection. It's not modified. Its elements are not moved, so they're not removed from there. We're just making copies of that in our current collection, so our collection grows. If our collection earlier had other elements, they will remain in the collection, and we have these additional elements coming from the other collection. Clear, as we discussed earlier, will remove all elements from the other array. Contains will return true if that element, if that value, if that item is in the collection. Otherwise, it will return false. We already discussed that. Now we have contains all. As we discussed earlier, the parameter here this time is not a single element, but it's a collection. So it will check each and every element of that other collection that comes with the parameter in the current collection. If each element of that other parameter collection appears in my current collection, this method will return true. If there's a single element of the other collection which I don't have in my collection, then it will return false. Is empty, as we discussed earlier, returns true if my collection has more than 0 elements. If it has no elements, then it will return true if it has no elements, if it's empty. Otherwise, it will return false. Remove all will, pay attention again, it has a collection parameter. It will look at all elements of the other collection, and if they exist in my current collection, it will remove them. If they don't exist in my current collection, no problem. So it's just like subtracting the other collection from my collection. So what remains after this method call is only the elements that do not appear in the other collection will remain in my collection. Retain all is just the inverse. Again, it has a collection parameter. So it will remove all values that are not contained in the given collection, which is the parameter, from the current collection. So it means it will retain only the values in this that exist in this parameter. Now you might think that this is equivalent to saying the current collection becomes equal to the other collection. Not necessarily so. So take it as follows. Assume that the other collection in the parameter has 10 elements. Okay? You will be removing all elements that are not in that parameter collection from your current collection. But since the other collection had 10 elements, but you had only 9 of them in your collection, the other elements will be removed and you will be left with 9 elements in your current collection, whereas the other one has 1 additional collection. Therefore, calling this method is not equivalent to saying the current object, the current collection becomes equal to the parameter collection. That's not necessarily true. It could be different. Size returns the number of elements in the list. And toArray, actually, it's not converting, pay attention, but it's creating an array from your collection which contains all elements in your collection. And the reason I'm saying it's not converting is your collection remains as a collection. So your collection is not lost. It's not being converted to an array, but an array is created, which is almost equivalent. It contains all elements in your collection, but what's created is an array. You still have the collection there. It's just not removed. So the Java's collection interface has defined some primitives for these methods. We already discussed some of them, so I will be very fast while going over these. IsEmpty returns true if the list contains no elements, otherwise false. Iterator we're going to discuss in more detail soon. It will be creating an iterator for us that we can later use to go over the list or the collection one by one. Remove removes that element, the first occurrence of that element. Size returns the number of elements, and toArray is just the method we discussed as the last method in the previous slide. It will create an array, this time of course an object array, because we don't know what the type of the linked list is, the collection could be. Java also provides us a collections class. Pay attention, it's not collection, it's collections. Here we have an S at the end. It's a class, it's not the interface. There's a collection interface and the collections class. The collections class provides some very useful methods that are to be used on lists, on both types of list implementations. That means here these methods here in the slide are used for linked list and array list. But also note that these are static methods. That means the collections class is just containing some useful utility methods that are useful for list implementations, such as the binary search method. The first parameter, note that since these are static methods, they are not instance methods. That means they don't belong to any specific object. Therefore, you cannot call it like object variable name dot, say, binary search, because it belongs to not the instance but the class. Therefore, you have to call it like collections dot binary search, collections dot replace all, collections dot copy, whatever. So it's not like my list dot replace all. Anyways, so when you call collections dot binary search, since it's not attached to any object, you should give the reference to the object for which binary search will work. So that's your first parameter list here. And the second parameter is what you're searching for. This will execute the binary search algorithm on the list. So remember, binary search, remember how it worked. It compares the median, that means the element in the middle of the list, with the value you're searching for. If what you're searching for is smaller than the median, then it should be in the first half. Otherwise, it should be in the second half. Therefore, it requires that the list is sorted. It will not work on a list that's not sorted. So make sure that the list is sorted. Copy copies everything in this list into the first parameter. So it's copying from source to destination. Now, in English, when we're talking, we always say source to destination. So you would expect source to be the first parameter, but it's the second parameter. And the reason is this just works like an assignment. You're assigning from the right-hand side to the left-hand side. That's why this is the order. Don't write it in the reverse order. Pay attention. Fill with will take this list parameter and replace all of its elements with the parameter that's given in the second parameter with this item. So that means you will have many duplicates. Note that whatever the size of the list was before calling this method, it will be the same. So for example, if you had a list of 10 different elements and the value here is, say, 52, all of the elements will become 52. You will have 52 10 times. Max will find the maximum element, min will find the minimum element. Replace all will not replace the whole list, but it will replace all occurrences of the item old value with the item new value. The other elements will not be affected. Reverse, remember we are talking about list, either a linked list or an array list, so there is an order. So reverse will change the order, it will flip the order. So for example, if it was sorted from smallest to largest value, now it will be sorted from largest to smallest value. Rotate will do a rotation. What we mean by a rotation is the following. If, for example, distance is +1, it will shift each element one position to the right. The last element will fall off from the edge. So instead of making it fall, it will be brought back to the beginning. So that's why it's called a rotation. If it's negative, it will just rotate in the reverse direction. Sort will do the sorting of your list. Remember, in the case of binary search, for example, it should have been sorted, which means first you should call sort, then call binary search. And swap will swap two elements, one at index 1 and the other at index 2. So it will switch those two elements with each other. All other elements will remain unchanged. Java's list interface again has the generic class parameter here. So we talk about again list of string or list of students. So list of any class type. So all of the methods that we discussed related to collection will be here, and on top of that it will add additional methods like add, specify the index, and then the type, as we already discussed this in the previous section. Get will return us the element at index given with the parameter, and the return value will be of type E, where E is, remember, this generic type. And index of will search for an element in the list and return its index. If not, it will return -1. Last index of will be similar to index of, but it will search for the last occurrence of that element. Remove will remove the specific element at the given index, and set will replace the element at the specific index with the second parameter here. And note that all of these additional methods that we add on top of collection E deal with indices. These were the things that were missing in the generic definition of the collection.